Yes, good afternoon. My name is Marvin Sendikadiwa, and I'm presenting to you our machine learning project. My fellow teammate is Joseph Lusoma. So, uh, our presentation is about business customer support call center insights. And in a brief, I'm going to be explaining to you how uh, our project operates. So, okay, over to the introduction. So, the quickest way to understand your customer base and pain points is by reaching out to them directly. This, however, has problems that are associated with it. Uh, Besides being time intensive and requiring a lot of trained personnel, it can only be done within a defined period. So we have come up with a more refined approach on how we can solve this problem by utilizing one of the company resources, that is the customer support department, the team that specifically the team that handles calls from the different customers. So this project is suitable for B2C based companies where there is a lot of interaction to the customers. So, and our problem statement is to provide measurable insights from calls that are received by customer support personnel at business call centers and improve the business service level agreements, the turnaround times, and the key performance indicators for the customer support personnel. So we want to get speech that is received from phone calls, and then to try to get insights from this data. So in a few slides to come, I'm going to explain what exactly we'll be gathering and how we'll be what we'll be doing to achieve this. So the objectives of this project are: one, to create an effective speech analysis system for phone call conversations in business support centers. Then two, to easily track the service level agreements or SLAs of phone calls made in business customer support centers. Then three, to get the average turnaround times for the issues that are raised by the customers. And finally, to accurately measure the key performance indicators for the employees that work with the customers directly. You realize that these employees, it's hard to measure their progress, whether they are good at their job or they are bad. And usually, what companies do, they currently to rate the service or the customer satisfaction. That after at the end of every phone call, usually with telcos, when you call a customer support center, you get a message to tell you to rate to rate the person that has worked on your issue. So we did some literature review around the existing problems, and in one of the related works, we realized that there is a speech sentiment analysis. So this work involves detecting emotions that are involved in speech, and to try to understand with the tone of the employee when they are reaching out to the customers. So, and then another related project is Zoho CRM, or Customer Relationship Management System, and Prosper Works. So these two are practical examples of this solution. However, they lack that speech analysis. So the research gaps that we identified in one of the writings, or in one of the articles that we came across, we realized that there is a gap in the practical applications of voice recognition or speech recognition system. So currently, speech is used by phone calls, by phones. For example, in your Google Siri, for example, Siri for iPhone, you can command it by saying something, or even Google Assistant or Alexa, but still those are the few examples, and that speech recognition has more capability that and problems that it can solve. That, for example, this one that we've presented, and the research questions that you might ask yourself about this is one, currently in the key performance indicators, customer support personnel is measured, or a KPI is measured accurately for customer support personnel. I mean, if you are to compare with the existing way how this is being done, there's still manual work involved, and it's still hard to quantify the work that customer support personnel has done. Same applies to turnaround times. So yeah, because currently what happens is that when a customer support personnel receives a phone call, they log it and into an issue tracker, but realize they can't log everything that has transpired in the phone call. So now to my next slide is the methodology, or the building blocks of how this program will work. So first we'll get input, or we'll record phone calls between the customer and the employee. Second, we'll store this audio call onto a server, and then third, we'll have an automatic speech recognition system. So this involves translating speech into text, which can further be aggregated or get measurable insights from that data. So then we'll index the text and then derive the customer-based strategies, and then we can predict the key performance indicators, or the turnaround time, and the SLAs. So this is a sample output of this solution. So we expect to get something like this, where we can get the average call duration, average callbacks, average resolution, and the customer call drops. So then the potential problems that are associated with this solution are: one, the noise in the background, because you realize that this environment is associated with a lot of back and forth exchange of words between fellow employees, and then on the other end of the customer, if they're an agent, they are working with in a loud environment. So that's one of the problems. The other one is the existence of multiple languages, and then the third is the domain-specific terminology. You realize that something means different in different areas, and those are the problems we're going to address soon. So then the solutions to these problems are: one, so for the noise, background noise in the phone calls, before this data is passed into the automatic speech recognition, it will need to be refined, or to go through a filter to remove the background of the phone call. Then second, for the multiple languages, then there will be need to train the models to work in different languages. For our domain, we are going to work with Uganda and English. And for the specific terminology, I'm going to explain this in a few where we talk about supervised learning. So yeah, so this is where supervised learning techniques come into. So this classification involves inputting, training your model, whereby there's a specific input and you expect, the expected output, the kind of data you're feeding into your model and training it with. So these are some of the techniques that we'll use, that is classification and regression. And then for unsupervised learning, where the techniques that we'll use are classification and dimension reduction. So for classification, we are for clustering, this involves getting all the phone calls and trying to analyze and trying to see the repetitions that are there between these phone calls, and trying to determine something that you don't know exists yet. So once this model, for the unsupervised learning model, which cannot be trained with, we can only feed it gigantic amounts of data and then see the output, and then we try to make sense out of the output. So yeah, we expect to utilize this approach as well. Then so on to my final slide. I'm going to try to explain the difference between precision, recall, accuracy, and F1 score sensitivity. So these are classifications of prediction metrics or performance measuring, and the most basic of them all is accuracy, where accuracy is computed by the true positives plus the true negatives divided by the true positives plus true negatives plus false positives plus false positives. So the problem with this approach is susceptible to cheat, this data set, and that's where the precision comes in. So precision is also another information retrieval method that can be used in Google search, for example. And for it, it takes a rather different approach where you get the true positives divided by the true positives plus the false positives. And this solves the problem of cheating that is faced by the accuracy technique. And then there's also the recall. So recall is calculated when you get the true positive rate divided by the true positive. So then for this project, I'd like to acknowledge a few research papers that is voice recognition and examination of evolving technology and its use in organizations. So because of this, we're able to identify the future works which this research was leading to, and then that's why we derived this this project, identifying the gaps that for the practical use of the voice recognition. And then I'd like to also acknowledge leveraging pre-trained language models for speech sentiment analysis. And what this one, the idea that we got on this is the approach that we'll take, because we realize that there is this speech-to-text conversion first, and then there's the text-to-insights conversion. So those are the two core touch points of this project. And this paper was quite helpful in trying to explain the approach that we might take. Thank you very much.